Hello and welcome to another GCSE revision video, and in this video we're going to be looking at scaling. In mathematics, if we keep the shape the same but increase or decrease its size, we call it scaling. The scale factor is the number we multiply each length by to get the end result. If the scale factor is less than 1, then the final object is smaller. If the scale factor is more than 1, then the final object is bigger. In order to know where to put the scaled up or down shape, we need a central point, sometimes called the centre of enlargement. So in order to enlarge or reduce a shape, we need to know two pieces of information: the scale factor and the centre of enlargement. The centre of enlargement can be inside or outside the shape. And that's pretty much all there is to it when it comes to scaling. Okay, well, so much for the theory. Let's have a go at putting this into practice. We're given a square and we're told, can you scale up this shape by a factor of 2 from the origin? Okay, so our centre of enlargement is the origin. So what we're trying to do is enlarge this square by a factor of 2. So basically the distance from the origin has to be doubled in each time. Well, there's an easy way to do that. We can just take the coordinates and double them, because the origin is the centre. So the bottom left corner is at coordinates 1, 1. So that's the object. So the image is going to be 2 times coordinates 1, 1, which is equal to 2, 2. So if I go to 2, 2, that's right there on the very edge. Okay, so the bottom right is at point 2, 1. So we want 2 times 2, 1. And that's equal to 4, 2. 2 times 2 is 4, 2 times 1 is 2. So that's going to be at 4, 2. That's where the image is going to be. So that's level with the top of the square at 4. So if my eyes, my eyes aren't that great, I'm going to zoom in a little bit so that I can see better. 4, 2 is right here, and 2, 2 is right here. Okay, so the other coordinates, the top left is at 1, 2, so the coordinates will be 2 times 1, 2, which is 2, 4. So this is 2 and 4 is up here. And then the top right is at 2, 2, so the image will be at 4, 4. Again, I can do that because the origin is the centre of enlargement. So my square, or my rectangle, it is a square actually, then all squares are rectangles, is going to be here. So that's my enlarged square where the centre of enlargement is the origin. Now this actually brings me back to something I've said earlier, that if you double the length, then the area will be not just doubled but quadrupled, which is scaled up by 2 times 2, or 2 squared. So we can actually very clearly see that the area is 4 on the original shape, and the lengths are 2 by 2, and the area is 4. On the image, the lengths are 4 by 4, and the area is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, which has been scaled up by a factor of 2 squared. So if you scale up the length by a factor of 2, you scale up the area by a factor of 2 squared. Okay, let's have another example. Right, so in this question we're asked, can you scale this triangle by a factor of 0.5 from the point -4, 6? Alright, so the point that we're scaling from is -4 here, 6, and in fact I'd like to view this a little bit better so that I can see clearer. So -4, 6 would put it from this point. Now I'm going to treat this point, -4, 6, as my new origin, and then I'm just going to do the same thing as I did in the last example. So this point here is 1, 2, 3, 4, 5, 6 squares down and no squares to the left or right. So 6 times 0.5 is 3. So I just want to go 3 squares down. So that's 1, 2, 3. And I'll put my vertex here. Now this vertex here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares down and 2 squares to the left. So I want to go 5 squares down and 1 square to the left. So that's 1, 2, 3, 4, 5 and 1. So that vertex will be here. And now this point here is still 10 squares down, but this time it's 1, 2, 3, 4 squares to the right. So it's on the same level as this one, but it's 1, 2 squares, because 4 times 0.5 is 4 divided by 2. So my triangle will look like this. And as expected, it's exactly half the size. And that's pretty much all there is to it when it comes to enlarging and reducing or scaling. Okay, I hope you found that helpful. Don't forget to like, comment and subscribe. Like if you want to see more videos like this. Comment if you have any suggestions for other GCSE maths related videos you'd like to see me make. And use that subscribe button and click notifications on if you want to be notified when I upload a video. Okay, if you're taking your GCSEs this year, I'd like to wish you all the best with your revision and all the best with your exams, and I look forward to seeing you in another video.